Hello everybody, get ready to do lesson 4.4 part 1 of pre-calculus math today. Email me here for course information and materials. 4.4 part 1, we got 6 points here of notebook taking students and 54 points here in your class worksheet today. Teachers, today's bell work is rounding your answer to 3 decimal places here. Students, solve these quadratics. Give your students about 5 minutes. Okay, welcome back for solutions to today's bell work. We have 2 quadratics here to solve. And for 137 up here, we're going to use the quadratic formula here. Plug into our quadratic formula our values from up here. So it would be 2 plus or minus radical 4 plus 20 over 2, which comes out to 3.449 and negative 1.449. 1 plus or minus square root of 6 in here. And then for number 2, 138, again using our quadratic formula. When you plug in your values from your original quadratic expression, you get negative 1 plus or minus radical 33 over 4, and this comes out to these 2 amounts here. So remember your quadratic formula, students. You could do it that way, or you could graph it as well to get these values. So that's your bell work for in your notebook, students. 4.3 definitions of trig functions are restricted to acute angles. In this section, the definitions are extended to cover any angle. When theta is an acute angle, the definitions here coincide with those given in the preceding section. So the definitions of trigonometric functions of any angle: let theta be an angle in standard position with xy a point on the terminal side of theta, and r equals x squared plus y squared, taking the radical of that sum, and that will be your r. So sine theta will be y over r, cosine will be x over r, tan theta will be y over x, cotan will be x over y, secant theta will be r over x, and then cosecant would be r over y. Notebook page 2 for 4.4 part 1. Because r equals x squared plus y squared, the radical cannot be 0, it follows that the sine and cosine functions are defined by any real value of theta. However, when x equals 0, the tangent and secant of theta are undefined. For example, the tangent of 90 degrees is undefined. Similarly, when y equals 0, the cotan and cosecant of theta are undefined. Put this in your notebook, students, page 2 of 4.4 part 1. Let's go into an example now of problems like this. Evaluating trigonometric functions. Let coordinate ordered pair negative 3 and 4 be a point on the terminal side of theta here. So negative 3 and 4 over here in quadrant 2. Find the sine, cosine, and tangent of theta. So find the cosine, sine, cosine, and tangent of theta. Referring to this problem here, you can see that x equals negative 3 and then y equals 4. And r would equal x squared plus y squared equals r. What is this distance here is the question. So we plug in negative 3 squared plus 4 squared equals radical 20. Then radical 25, as you well know, is 5. So you have a sign here, theta, y over r, which would be 4 over 5. So this would be 4 over 5. And then cosine theta would be x over r, would be the negative of negative 3 over 5. And then tan will be y over x, so it would be negative 4 over 3. So that would be how you would come up with those. determine the exact values of the 6 trigonometric functions of the angle theta. Here's our angle theta, and then here is our point on the terminal side of this angle theta. Down here, students, this is yours. I'm not sure if I do this for you, but teacher, you should wait and let your students attempt both of these and then see if they come out on the right side here. Okay, after you've waited, teachers, here it would be your tan, cosecant, secant, and cotan of this situation here. And then over here we find out our r is 5, so you should always figure out what your r is first before you can do your other functions there. So our r is 5, be 4 squared plus 3 squared is radical 25 is 5, so now you can do the rest of your tan functions. And then down here, your r is 64 and 225, and then the radical of that will be 17. What does that come out to? It'd be 289. So, and then now you can find the rest of your trig functions now that you have r, and you have your point here on the terminal side. Here's your other functions here, tan, cosecant, secant, and cotan, now that you find your r. Okay, notebook entry, slide number 5, students. The signs of the trigonometric functions in the 4 quadrants can be determined easily from the definitions of the functions. For instance, because cosine theta equals x over r, it follows that cosine theta is positive wherever x is greater than 0, which is in quadrants 1 and 4. That would be where your x values are greater than 0. And then here is a graphic here of quadrant 1, sine is positive, cosine and tan, and then quadrant 2, sine would be positive, cosine and tan would be negative. Quadrant 3, sine would be negative, cosine negative, tan would be positive, and then quadrant 4, sine would be negative, cosine would be positive, and then tan would be negative. Page 6, example 2, evaluating trig functions. Given sine theta equals a negative 2 over 3 and tan theta is greater than 0, find cosine theta and cotan theta. So we know our sine here is negative 2 over 3. So again, here is our chart up here showing what our sines would be in our 4 quadrants up here. Note that theta lies in quadrant 3. So quadrant 3 here, sine is y over r. So it would be a negative. So over here would be sine would be negative here, and then it could be. Do we have a limitation up here? And tan would be greater than 0. So over here, tan would be less than 0 in quadrant 4 because tan is x over y, and x over y would make it less than 0. Over here, tan would be positive. So it has to be quadrant 3 here, which is in which the sine is negative and the tangent would be positive. So this is the only quadrant in which your sine is negative and tangent is positive. Moreover, using sine theta equals y over r equals negative 2 over 3, and the fact that y is negative in quadrant 3, your y is negative down here, you can let y equal negative 2 and r equals 3 because x is negative in quadrant 3. So that is your kind of like your wordy explanation for how sine could be negative and tan could be positive. That is the reason why here. You can let y equal negative 2, which would be down here, and then r would be positive. So that would be the reason why that would work. Because x is negative in quadrant 3 too. So x and y are negative. That's what makes your tan positive. And then for your sine would be negative, and then your r will be positive. So again, basing off this chart, so the negative of 9 minus 4, which would equal the negative square root of 5, you have the following now. Cosine of x over r would be a negative 5 over 3. This will be your cosine value for that theta, for that angle. And then that comes out to the negative 0.75 approximately. Cotan would be a negative square root of 5 over negative 2, so that would be your x and y here. It would be a negative a radical 5 over negative 2, exact value for cotan, and then which comes out to 1.12 approximately for your cotan. Okay, let's try one. In these exercises here, find the values of the 6 trigonometric functions of theta. So we have tan theta equaling negative 15 over 8. And then here's our constraint. Sine theta has to be negative. So for sine to be negative, and then down here, students start on this. Teachers, give your students some time to try both of these on their own. Give them about 5-6 minutes. And then for up here, for the first one up here, tan would be y over x. So it'll be negative 15 over 8. And then our r would equal 17 for this one. So by squaring both of these and then taking the square root of them. So our sine would be y over r, which would be negative 15 over 17. And then our cosine would be x over r, would be 8 over 17. And then cotan would be the reciprocal of our tan here, which would make it the negative 8 over 15. Cosecant would be r over y, would be the negative of 17 over 15, and then secant would be r over x, which would equal 17 over 8. Down here, figuring this, cotan is less than 0, so it's negative. So cotan is less than 0, that gives us an x of negative square root of 15. So sine would equal y over r, be 1 over 4. Because we know cosecant is 4. Then cosine would be x over r, would be the radical 15 over 4. Tan would be y over x, so it would be the negative radical 15 over 15. Cosecant would be 4, we know that. And then secant would be the negative of 4 times square root of 15 over 15. Okay, so getting on to our next page here, page 9 of our classwork here. Trigonometric functions of quadrant angles. Evaluate the sine and cosine functions at the angles 0, pi over 2, pi, and 3 pi over 2. So in this situation here, 0, here's pi over 2, pi, and then 3 pi over 2. To begin, choose a point on the terminal side of each angle shown. For each of the 4 given points, r equals 1. So here's your r here. R is equal 1 for each one of these. So for sine 0, we have y over r. Y over r is 0 over 1. So it equals 0. Cosine 0 would be x over r. Be 1 over 1 is 1. And then xy would equal 1, 0. So that would be for 0 there. You got sine and cosine. And then for sine pi over 2, which is up here, y over r would be 1 over 1 equals 1. Cosine pi over 2 would be 0 over 1, which would be 0. So xy would be 0, 1 up here. This is your ordered pair for pi over 2. And then for sine pi over here, y over r. And we have 0 over 1, so our r here is 1. Cosine pi would be x over r, be negative 1, 1. would be -1, be your exact value. And then xy ordered pair would be -1, 0. And then for sine 3 pi over 2 here, the y over r being -1 would be our y value, and then 1 over our r. Cosine 3 pi over 2 be x over r, be 0 over 1 would be 0. So x over xy would be 0, -1. So in these exercises, evaluate the trig function of the quadrant angle. So what would secant theta be? Students, this is yours down here, tan of pi over 2. Okay, so we're going to evaluate trig functions at a quadrant angle here. Secant of pi would be r over x, and in this case r is 1, and then x at pi would be -1, which equals -1, and then tan of pi over 2, y over x, so our y value would be 1, or x value would be 0, so it would be undefined since pi over 2 corresponds to 0, 1. So tan pi over 2 would be undefined. Page 11 in our classwork, reference angles. The values of trig functions of angles greater than 90 or less than 0 can be determined from their values at corresponding acute angles called reference angles. So the definition of a reference angle is theta. Let theta be an angle in standard position. Its reference angle is acute angle theta prime formed by the terminal side of theta horizontal axis. So the reference angles for theta in quadrants 2, 3, and 4. So this would be a reference angle here for quadrant 2. This would be theta prime, this angle here. Since you've passed your the y-axis here and you're over in quadrant 2, now your reference angle would be over here on your horizontal axis here, your x-axis. So your reference angle will be theta pi would be here. So theta pi would equal pi minus theta. So this would be pi over here, it would be pi minus theta here, would give you your reference angle here. And theta pi would equal 180 minus theta. So 180 minus theta would give you your theta pi here. And then in this situation here where your terminal side is in quadrant 3, your reference angle here, theta pi, would be theta pi would equal theta minus pi. So this would be your pi here. So theta minus pi would be your theta prime. And then theta prime would equal theta minus 180 degrees. So theta prime, another way of getting your reference angle here would be subtracting from your theta here, this total angle here, theta, subtracting 180 from that, and that would give you your theta pi here. And then when in quadrant 4 here, your reference angle is up here at this angle here, which would be 2 pi. So it would be theta prime would be 2 pi minus theta. So it would be 2 pi minus theta here would give you your theta prime. Theta prime would be 360 minus theta in degrees. So it would be 360 minus theta here. That would give you your reference angle in quadrant 4. Okay, so getting on here to page 13 of your classwork sheet today. Finding reference angles. Find a reference angle theta prime. This little tick mark, that means prime there, theta prime. So meaning it's different than theta. It's 1 up from theta. So let's find a reference angle when our angle is 300 degrees. So because 300 degrees lies in quadrant 4, the angle it makes with the x-axis is then 360 minus 300 would equal 60 degrees. So our reference angle would be, our theta prime would be 60 degrees when our angle is 300 degrees. We go 360 minus 300 would give us 60 degrees here for theta prime. And then what about when theta equals 2.3? So that, I suppose, would be radians, because 2.3 lies between pi over 2, which is 1.5708, and pi, 3.1416. It would be somewhere over here, would be theta equals 2.3. So our reference angle will be here at pi. So theta prime would equal pi minus 2.3 here. Here is our 2.3, theta is 2.3. So to get that solution, quadrant 2 and its reference angle is theta prime would be pi minus 2.3 would equal 0.8416 radians here for in this situation where theta equals 2.3. The reference angle would equal 0.8416 radians, meaning this distance here, radians, okay? And then for theta equals a negative 135 degrees, first determine that a negative 135 is coterminal with 225. So it's coterminal over here. Negative 135 is this side here, which is coterminal with 225. 225 is here, which lies in quadrant 3. So 225 and 135 are coterminal. So the reference angle here would be 45 degrees. So it'd be theta prime would be 45 degrees. So it'd be 225 minus 180 would be one way that you could figure it. 225 and negative 135. So your pi here, this would be your side that you would start to find your reference angle, would be 180 degrees. So it'll be 225 minus 45. Or rather, I'm sorry, 225 minus 180 would be 45 degrees, would be your reference angle. So the reference angle is 225 minus 180 equals 45 degrees. So let's try one. Find the reference angle theta prime. So theta is negative 1.8, obviously radians. And down here theta would equal 4.5 radians. So sketch theta in standard position and then label theta prime. So to do that, theta equals negative 1.8 lies in quadrant 3, because pi is 1.5 or something like that. Pi minus 1.8 would be 1.342. So that would give you theta prime for that. And then the sketch of that would be right here. Theta prime would be 1.342. Here's your reference angle here at pi. So pi minus 1.8 would equal 1.342. And then down here, 4.5, theta lies in quadrant 3. 4.5 minus pi, quadrant 3 again here, would be 1.358. And then the sketch of that will be right here would be your angle. Theta prime equals 1.358 in radians. So theta equals 4.5. Was it 3.416 whatever? So you subtract 4.5 minus pi, and you would get this 1.358 radians for your reference angle. And that's 4.4 part 1, pre-calculus math. Email me here for questions or other instructional materials. Thank you very much.